So, good afternoon. We're happy to be here today. I'm Shira Shoval, and this is Arielle Blonder. We are a textile designer and an architect working together on collaborative design research for the past 6 years. Textiles and architecture have always been connected. We live inside fabrics. Textiles not only wrap and protect our bodies, but also provide us with shelter from the outside world. In 1922, Annie Albers, the renowned Bauhaus textile designer, entered the weaving workshops of the Bauhaus because they were the only ones open to her as a woman. There, Albers embraced the possibilities of textiles, experimented with raw materials and structures to create original weaves and prints. In her essay, The Pliable Plane, Textiles and Architecture, Albers examines the relationship between the two disciplines and what sets them apart from other methods of making. If the nature of architecture is the grounded, the fixed, the permanent, then textiles are its very antithesis. Both construct a whole from separate parts that retain their identity. New methods are developing, affecting both building and weaving, and are adding increasingly to fusion as opposed to linkage. It seems that textiles and architecture attract each other, making guest appearances in each other's disciplines. Embracing architectural structures and fabrics creates extraordinary fashion, as seen here by Issey Miyake, while textile facades and buildings bring movement and new perceptions of space, like in this early work by Shigeru Ban. But is this just inspiration, or one discipline embracing a principle of the others? Or maybe, since these disciplines are so inherently linked, we could expect a new kind of dialogue between the two.
In the past 2 or 3 decades, we've seen a proliferation of notions about this mixing of disciplines. And it has flourished in every field, from research to education to project management, business initiatives, and of course, design and whatnot. And out of the multitude of notions and terms, we gathered 3 dominant ones, being multidisciplinarity, interdisciplinarity, and transdisciplinarity. Basically kind of all sounding the same, right? So in this process of trying to figure out which is which and what's the difference, based on several academic papers of very different fields, we did this visualization. And in this visualization, you see the 3 disciplines represented as shapes and their respective contribution. So we start with multidisciplinarity. It's the most simple one, kind of additive process where each discipline contributes in its field, in its domain, and it adds up into this, let's call it a project or a house, where still each discipline remains kind of distinct. Moving a step up into interdisciplinarity, here we can see that the project or the whole is constructed out of the overlap between the disciplines. So out of these links, a synthesis is created, and we have an interdisciplinary project. It gets more complicated in transdisciplinarity, where boundaries are blurred, and we have a kind of a more holistic approach to the project, where you cannot differentiate between one discipline and the other, and they are all kind of mixed and blurred. So after several years of fruitful collaboration between a textile designer and an architect, looking back onto our works, we wondered maybe we could suggest or find out a 4th model, something a bit different, that could be represented in our work. So for that, let's start with this piece called Refroze, something we did in 2016, stemming up from our joint interest in first sculpting or structuring textile on one hand, and our love for composite material on the other hand. So this piece is made out of fiberglass, prepreg in that case, being used usually for aviation, and through stitching this element with just simple threads, we actually create these undulation or complex morphology into what becomes later rigid and structural. Now, if we think about it not as complex morphology or undulation, just in basic textile terms, this is pleats and ruffles. Okay, and then we get a piece that talks about structuralness, how we actually take a soft material, make it structural, about morphology, flow, transparency, and more. So composite material, this piece is made of composite material, is actually this combination between very different materials. In that case, it's resin and polymer matrix, that together here comes the 1 + 1 = 3, gets us a whole that is completely different from its part. These parts remain functional, and the capability go far beyond the contribution of each material in itself. So let's look at the definition. So we see that both fiber and matrix retain their physical and chemical identity, yet they produce a combination of properties that cannot be achieved with either of the constituent acting alone. So the contribution of the element, one of them is making actually most of the work, that's the fibers doing the structural work, but it's completely meaningless without the matrix that gives it shape, maintains it in place, and gives it durability. And it is this combination between the elements, this fusion, that if you remember, Annie Albers was talking about it before, that interests us. Because when you use composite material, it's not that you're using a very performative material that is light and then strong and gives you a lot of capabilities, but it introduces you to a different strategy of design. This is composite design, where instead of assembling elements, you fuse them into a fusion. Mechanical bonding that we're used to do in every element that we do as architects or designer goes towards chemical bonding. And suddenly, it's not about this element that combines these two things, or as we name it, the join, but it's about their interfacing one with each other, where a mass actually transforms into layering. So, how can composite design become a research methodology? Could it be a composite way of thinking? How can we use these understandings in creative collaborations between different disciplines? And in our case, we want to show 3 different disciplines. So that's the architect, the textile designer, and the physicist, Professor Eran Sharon.
In his lab at the Hebrew University, Professor Eran Sharon researches stress-induced changes in the mechanical properties of organic materials, basically how internal forces in a material create its morphology, rather than an imposed external shape made by molds or tools. This first physical experiment shows some parameters that influence the created shape, such as orientation, scale, shape, and size. While in his lab, I realized that although we speak different languages, we understand each other. Because actually, aren't textiles always given shape through stress? How are ruffles created? Frustrated Materials is an ongoing project bringing together the studio and the lab. Mathematics meet parametric thinking and craft know-how to create 3D surfaces from a flat material. We stretched 2 sheets of latex rubber in opposite directions and then merged them together, creating a stressed or a frustrated material, as each layer wishes to retract to an opposite direction, but is forced to stay put. Carefully cutting the surfaces of the merged latex releases an outburst of energy, creating different shapes and openings. Parameters such as angle, length, and geometry are tested through each incision, controlling the behavior of the material and enabling us to create an alphabet of shapes. Through parametric exploration and physical prototyping, we expanded the palette of shapes anticipated by science, gaining implicit know-how that relates geometry and structure. From this alphabet that could create infinite stories, we looked to nature as a source of inspiration for complex radial patterns and made 33 tiles designed as mandalas or flowers, if you wish. These works were shown in our exhibition, Frustrated Materials, at PeKA Gallery in Tel Aviv, curated by Shlomit Bauman. Though not textile, nor architecture, nor scientific paper, we can identify the layers of textile and architecture approach, which together enable a new way of expression. Our project Frustrated Materials set the ground for a long-term dialogue and explorations with Professor Sharon. The next step was our move to another unknown territory, the Ceramic and Glass Design Department at Bezalel Academy. We were invited to the residency program at the department in Jerusalem to realize a project in ceramics. Ceramics, in difference to textiles, but resembling construction processes, are built into shapes using different methods, such as molds, wheels, and sculpture. But we know nothing about these methods. Could we create shapes using our frustrated knowledge? Could ceramic material turn to 3 dimensions by applying the right stress? Here again, we are bringing our parametric material exploration, infused by both architecture and textile design, to unravel the inherent connection between geometry and structure. By combining 2 very different and incompatible ceramic materials, quite a taboo in the department, and through a unique process closely controlling drying and firing stages, we are able to create three-dimensional structures from flat material. Currently, we are still exploring the limits of shape, size, and parametric control, and will be developing this material research into an exhibition at Bezalel this coming fall. In conclusion, we feel that in frustrated ceramics, once again, 1 + 1 = 3, and that by using composite design, we are creating a whole which is larger than the sum of its parts, and enabling each discipline to ask different questions and gain new knowledge and perception.